Today's video starts on page 17, the problem of the day. You are going to follow these directions carefully and solve these three problems. They're a little tough. Give it your best. Try to do this on your own, and we will go over them in class tomorrow. Subtracting terms, one term by or from another. When subtracting terms, you must use parentheses because now our terms may be a binomial or a trinomial, could be just a monomial, but if we have more than one term, we have to distribute the subtraction or the negative to the entire term. So you got to be careful because remember, subtraction is not commutative, so we really have to pay attention also to the English here. What would you get if you subtract 9 take away 7 from 12 take away 5? I know that if the operation is subtraction and the words used are usually two words like subtract from, fewer than, less than, subtracted from, things like that, I know subtract from, that the English and the math is in reverse order. Subtracting 9 take away 7 from 12 take away 5, that 12 take away 5 comes first. And you're subtracting 9 take away 7 from it. So these switch order, that's what I mean. When it's two words, the order of the numerical part switches. 12 take away 5, so I'm going to do my order of operations, is 7 minus 9 take away 7 is 2. Well, 7 take away 2 equals 5. So that answer is 5. What if you subtracted the 2x plus 7 from 5x plus 4? Again, subtract from. So I'm going to switch the order of this. 5x plus 4. Subtract from it 2x plus 7. Now I have to distribute this negative because I have algebra terms here. Up in the first one here, 9 take away 7, I can do that. I can do the order of operations. Here, I'm going to have to distribute this negative, and I write it as -1, and I multiply the second binomial by -1. So -1 times 2x, -2x. -1 times positive 7, -7. Now I'm going to put my like terms together, combine like terms. Should have put more space on this. 5x and -2x combine to 3x. Positive 4 and -7, different sign, subtract. So 7 take away 4 is 3. Take the sign of the larger number, which is the larger absolute value is 7. So 3x minus 3 is my simplified expression. Watching the order. Subtract 1/2 x take away 9 by -4x plus 9. Well, this I don't have to switch the order. That is correct English and mathematical order. So it's 1/2 x take away 9 minus -4x plus 9. Now I've got to distribute this negative to both of these terms. So I put parentheses around it and then do the distributive property. -1 times -4 is positive 4x, and -1 times positive 9 is -9. And when I combine like terms to simplify the expression, 4x is plus 1/2 an x, 4 1/2 x. And -9 and -9, same signs, add and keep. I get -18. 4 1/2 x, -18 is my simplified answer here. Subtract 7x from 18 plus 9x. Well, there's those two words. So I know this order switches. So 18 plus 9x, subtract from it the 7x. It's only a single term. Yes, I could put this in parentheses, not needed. Don't need to put it in the parentheses, so I'm probably not going to. I'm going to erase that. So take away 7x. It's only a single term. I don't have to distribute. So 9x, take away 7x's gives you 2x, and yes, I'm going to put that first. because I like to have my variable term first, correct algebraic order here, variable term and then constant after. So yes, it is the same answer, 18 plus 2x, just not best form. Best form is putting the algebra first, 2x plus 18. Find the difference of 6x minus 89 and negative 4x plus 9. Find the difference of. That's okay. That order is the correct numerical order as well. So the mathematics is 6x minus 89 and subtract, difference means subtract, negative 4x plus 9. So I have to distribute that negative. Negative 1 times negative 4x, positive 4x. Negative 1 times positive 9 is negative 9. Now putting my terms together, like terms, I have 6x's and 4x's, which gives me 10x and negative 89 and negative 9. Same signs, add and keep. I'm going to get negative 98. And that's my final simplified answer there, 10x minus 98. What is 3/4 x plus 7 less a 4th x take away 9? What is less? Okay, so it's not less than, it's not subtracted from, this is correct order. So 3/4 x plus 7 subtract 1/4 x minus 9. So I have to distribute this negative to both terms in the binomial. Negative 1 times 1/4 x, negative 1/4 x, and negative 1 times negative 9 is positive 9. So now putting like terms together, I get 3/4 x minus 1/4 of an x. Well, that's 2/4 of x, which is a half. I'm going to simplify that. So a half x and positive 7 and a positive 9 makes positive 16. So simplest form, 1/2 x plus 16. So a little practice of what does it mean to subtract algebra binomials or monomial in the one example. The next part, write an expression for the missing dimension of each shaded figure. Okay, so the question marks here in number 49 and 50. And a multiplication expression for its area. Then expand and simplify that multiplication expression. Okay, so area is multiplication. And for the shaded area. Okay, so I'm not using the entire, well, it looks kind of like a square or a rectangle. We'll call it a rectangle. Not only the shaded. So I do have to find this, what's this question mark here? Well, I know the whole side is 14. And if I subtract from it the x minus 3 part that's given, I'll get this question mark. I'll find that missing area. So that's the first thing you have to do, the missing dimension. So 14 minus, oh, it's a binomial, so I'm going to have to put that in parentheses, which it already is, and distribute that negative to both terms. So negative 1 times x, negative 1 times negative 3, positive 3, and I have 14. Take away x plus 3. Oh, we can simplify that. And I get negative x plus 17. That's that question mark. That's the length or width of this little rectangular piece that I'm now going to find the area. Write a multiplication expression for its area. Well, the area of a rectangle is length times width, so formula. Now I'm going to plug in the values. And I have 12 as a length or width times this little expression that I found here, negative x plus 17, that's the dimension down here, times the 12 will give me the area of this shaded rectangle. So distributing, then expand and simplify the multiplication expression. Okay, so I'm going to expand, distributing 12 times negative x, negative 12x, and 12 times 17, 204. Then expand and simplify. Yep, okay, so we get negative 12x plus 204. This is geometry, so I want to label my answer. This area is no units given, so units squared. So I got a formula, I multiplied, expanded that, and answered it with a label. So negative 12x plus 204 units squared. Number 50 is a triangle. Well, I know the formula for a triangle is area equals 1/2 base times height. And this question mark, if the entire length there is 16 and the known length is 2x, so 16 minus 2x will give me this question mark. But I'm going to rewrite it in good algebraic form and put my algebraic term first, negative 2x plus 16. That is a negative 2x and this is a positive 16. So now I have my base of my triangle. The formula for a triangle is area equals 1/2 base times height. So 1/2 times that base, which is negative 2x plus 16 times my height of 8. I'm going to do half of the 8 first. And use the commutative property and say that's 4. And then distribute that 4 to the negative 2x plus 16. And I get negative 8x, 4 times negative 2x, negative 8x, and 4 times the positive 16, positive 64. So I put that in, it looks correct. I got to label this, negative 8x plus 64 units squared. Write an expression for the area of the figure. Expand and simplify. Well, now I have a rectangle plus a triangle. A little bit more work here. So the area is a rectangle plus a triangle. I don't have any unknown sides. I have all my information that I need. So the rectangle is 10 by 2x minus 3y, length times width. And my triangle is 1/2. The base is 6y's. And the height, we know, is this 10. So times 10. Simplifying, I get 20x minus 30y's. And half of 10 is 5. 5 times 6y is 30 plus 30y's. Ooh. Negative 30y's and plus 30y's, well, those are just going to cancel each other, right? So my answer is 20x. Again, no units given, so units. Then you don't have to write out the word units. Units squared. And that's it for today's video.